Hello, this is a note on a special topic, special aspect of celestial navigation. And I show here we have a textbook on celestial navigation, and this is our main reference always for those who want to learn it from scratch. I'm discussing a subject here now that is mostly, in large part, for those who already know celestial navigation. But just as a bit of a reminder about how this works, or one of the key factors of how celestial navigation works, is that when we take sights with the sextant sights of stars, we have to know where the stars are. That's a special phrase, know where the stars are. I can't say they're northwest of here or they're in Ballard or whatever. But what that means in celestial navigation is we know at the given moment in time what is the latitude and longitude on Earth where that star would be directly overhead. So there's a latitude and a longitude for every star where it's directly overhead. Now that obviously changes as the Earth rotates. That tracks along this globe here. But so that's a critical point. And then ultimately, and again, I show some pictures here that look a little scary, but they're not at all. None of this is involved in celestial navigation, really. It's just the background. You do celestial navigation, you never look at diagrams like this. But anyway, here's a person here, and then here's what's called the GP, geographical position, the point right underneath the star, or the sun, or the moon, or a planet. And that latitude and longitude, the latitude of that body on Earth is called its declination. That's from here up to here. And the longitude of that point is called the Greenwich hour angle, which is measured back here from Greenwich all the way over here. So what we need to know in celestial navigation is at any moment in time, by the second, where is the GP of all the celestial bodies we want to use with our sextant. So that's the background that we're after. Now, here's the point of the note. There are in a sense two official sources for this data. One is called the Nautical Almanac, and another is called the Air Almanac. And some mariners actually like this Air Almanac. It was originally meant it is still meant for those doing celestial navigation with an aircraft sextant flying underway. That's not done in routine very much anymore, but it's certainly a crucial aspect of modern navigation. That is, celestial navigation is, after all, how the space capsules are navigated and so forth. Satellites and rockets ultimately use some form of celestial navigation. But that's not the issue at hand. We're down back on the water, and we need to know where those the latitude and longitude, GHA, and declination of these bodies are. So the standard way is called the Nautical Almanac, and that's still the method that we recommend, the Nautical Almanac. And I'm going to be going over a few reasons why that's true. And then, but there is this Air Almanac, which is an alternative. And so we're looking now, in this talk, I just want to briefly discuss what's the difference between the Nautical Almanac and the Air Almanac. So first of all, let's look at just some of the financial facts. The Nautical Almanac is if you buy it, official government edition, they're orange like this, they're $52. And if you buy the so-called commercial edition, that's one company has the rights, has the license, they pay for that to print this book and sell it themselves, and they sell that for $30. Now, in principle, these two are identical. Not exactly the case. The structure is different, the paper is different, one thing or another, but it's basically should be in principle the same content. So that's $30. Now here's the interesting thing, and this includes the GA. We'll see that in a minute. We'll look at some pages. These two include the declination GHA plus other correction tables. Now we can get that same GHA and declination from the Air Almanac. The Air Almanac, on the other hand, is it's made by the same agency, United States States Naval Observatory. And that agency then, however, puts this one online. You can download as a PDF for free, or you can pay $28 or $30 and get a CD of it. But you can get a PDF for free. And so that's a big difference between those two. But we recommend, and I'm going to show the differences here, but we recommend still the Nautical Almanac. In large part, the layout's different in this one. We'll see that in a minute. But in large part, there's other reasons I'll get to right at the end. But in large part, we recommend the Nautical Almanac so that we standardize the training of the subject. We don't want 2 or 3 different tables and layouts and procedures for getting this data. It's a lot easier if everybody uses the same system, same definitions, same table designs, and so forth. And that's part of the reason we recommend the Nautical Almanac. There's other reasons. I'm going to mention those at the end. Very important reasons that we mention at the end. So here's the Air Almanac. It's you can get it. You just go to the government bookstore. This link. Oh, I forgot to say, I'm basically discussing this based on an article that's online. This article we're looking at right this moment, and I will put the link to that. Those who want to look at this discussion more leisurely, get actual links you can click and have a printed copy of this comparison, then you go to this article we're looking at right here. So this is my sort of outlines for this video presentation. So you can click that link and actually get the 2019 issue. And you go up here to the government printing office, and then you could put in Air Almanac, and you'll get things like this. And we'll see 219. This says CD-ROM. This one will be about $28. And then find the one that's without any CD. This is a free PDF. And I'll just note to you so it's not a surprise. What you have to do is you have to set up an account, totally free and presumably non-invasive. And so you have an account. Then what you have to do is technically buy this at zero charge. You put it in your cart, you buy it, and then you check out, you pay $0, and they accept your payment of $0, and then they will email you a link, and from that link you download the document. Now, one of the things you'll notice is, now again, what are we here? This is October the 26th, so it's clearly not 20. It's October 26th, and we don't see any 2020 version. Now, that's a concern for the moment, which I'll explain why. The 2020 Nautical Almanac is already out. Generally, these are both out September, October of the preceding year. But this one's not out yet. So we have to find out when that's going to come out. One of the issues here, which is noted here, is that for reasons not totally understood, the U.S. Naval Observatory, USNO, has shut down their website a few days ago, October 24th, and with the announcement, no longer there, but you can see if you had looked earlier, you would see it was going to happen. They've just closed down their whole website for 6 months. That's a long time, and we don't know for sure what the reason is. Presumably, it's a serious one because that's not the normal way to do things. But anyway, we have to just keep a lookout if we want the 2020. Presumably, it'll be there later on. So that's the Air Almanac. How to get it later on. And there's a reminder there. So here then, now for comparison, we have in this printed document, we have these pages. Here's a layout from the Nautical Almanac. See and you can click these for more detail. So here's a UT, Universal Time, and then it's look at this, it's every hour. They give the date every hour, and here it is. Here's a longitude, GHA 178.36, and a declination here. Now, just a reminder to those, in celestial navigation, we put the north in front. So this declination, north 22 degrees, 02.0. Now, for a latitude, you would say 22 degrees, 2 minutes north. You put the N on the back. So you put the N in the front for declinations, you put the N in the back. And so that's, and here's a page that covers 3 days, 12, 13, 14. And then the moon and so forth, and then the sunrise and sunset times. One other sort of side note, look, there's 3 pages here, but there's only one set of sunrise, sunset data. That always in the Nautical Almanac applies to the middle page. Okay, so that's the way that's set up. And then there's a second page. And these are facing pages in the Nautical Almanac where they list this is for finding the reference longitude for the stars, Aries, and then they list the planets. And these are the magnitudes of brightness of the planets, and then all the lists of the navigational stars. These stars are listed here alphabetically. There's another place in the almanac where they list them by number. Each of these stars has a unique number. Always true, like whatever that is, that says some number. And so this is, these are the planets. These are the visible planets that you could see and navigate by. Mercury is a visible planet, but it's not listed in the Nautical Almanac. Actually, that's interesting. That's another difference. I think Mercury is listed in the Air Almanac. But Mercury is generally too close to the sun to be useful for navigation. All right, so now let's go and see, here's what it looks like in the Air Almanac. So the first thing that's different, we notice they don't give it every hour, they give it every 10 minutes. So in one sense that looks like it's a little better, but that certainly doesn't matter. In both cases, you take whatever it's given. If I have to do the minutes and seconds correction using a special table. Back here it's called the Increments and Corrections table. That gets me from just July 13th at 2 o'clock, then I can get down to 2 hours, 30 minutes, and 20 seconds. I make the minutes and seconds with what's called the Increments and Corrections table, whereas when you go to the this almanac, Air Almanac, it's called Interpolation Table. But it's the same process. You take it the nearest time out of here and then fix it up. Then, well, let's see what else is new. Okay, look, here they list day 194. That's the day of the year. Now, that turns out to be a really handy number, and that the Nautical Almanac knows that's a handy number as well, because they have a special table, but it's not on the daily pages. It's a special table in the back of the book or somewhere there, and it lists for every day of that year, you know, July 13th, 14th, 15th, each has a day of the year number. And that's usable in ocean navigation for a couple things. One is when you make a long distance ETA, you know, you got like a week or so of 2 weeks travel or something across the ocean, you have to predict the day you're going to arrive for various reasons. And that's a lot tidier computation when you deal with the day of the year rather than 30 days has September, etc. That gets to be tricky. And the other where it comes into account is if you're doing really pure, old-fashioned, real school celestial navigation, then you're navigating by your watch. I'm not turning on the GPS and having it tell me what the UTC is, or Greenwich Mean Time. Those are the same, UTC. I'm not going to turn on my GPS and have them tell me the time. In real basic celestial navigation, you always navigate by your watch, and your watch always has an error, and you figure that error based on the watch rate, and the rate is how you have, like you say, you have maybe 0.3 seconds per 10 days, and then you set it on a given date, and now it's a different date, so I have to subtract dates and so forth to figure my watch error, and that day of the year then becomes real handy. Anyway, so that's put up. Here they list it every day. That's in a sense kind of nice. But notice this, they have only 1 day per page, and that they only have one type of daily page. It includes the sun. This is again, Aries is a reference longitude for stars, and then the planets. But here's a subtle thing to look. They have Mars, Jupiter, Saturn. This is the same day, July 13th. We go up here. They have Venus, Mars, Jupiter, and Saturn. So there's already a flag of some kind, especially because celestial navigators know that Venus is one of the most important bodies. Whenever Venus is out there, we want to use it. It's so bright. It's the brightest thing in the sky. And so we can take Venus sights in the morning, or no, let's say in the evening twilight, the stars won't even be visible, and we can have a whole series of Venus sites already taken, and so forth. So we take them very early. Likewise, in the evening, in the morning twilights, the star, we can save Venus for last because all the stars can be faded and Venus will still be up there. So in short, Venus extends the period of time that you have, which is not real long, anywhere from 20 minutes to 30 minutes. This can really stretch it out quite a bit. So Venus is valuable. But they don't list, but these guys down in the Air Almanac don't list it. And why is that? The reason is, in fact, even though it's here in the Nautical Almanac, at this particular date, maybe even the sequence of dates, this Venus is not even usable. It's not usable at all. And the reason it's not usable is because it's too close to the sun. So if you go into this article and you look at the latitude and longitude of where Venus is located, and then you come down and look at where the sun is located. Oh, it's back up here. You look at where the sun is located and where the Venus is located. You'll see these guys are almost on top of each other. Now, and so forth. We'll come back to this a little bit later. So Venus is too close to the sun. You would never use it. So the Air Almanac, that just takes that into account. They don't bother telling you the coordinates of something you can't use, which is, in one sense, a nice feature. And so let's go on down. What else? Any other new or different things here? These numbers, again, are the magnitudes, the brightness of the bodies, all on one page. Okay, let's go down. Okay, so this idea of skipping Venus when it's not there can apply to other planets. So here's a day. What day is this? July 20th. Then they've got Jupiter and Saturn. And then they just simply tell you all the rest of the planets are too close to the sun to be useful. And again, this can happen with the moon. You see, the moon, certain times of the year, you got a new moon, brand new moon, or they really should, I don't know how they do this exactly. You could have a new moon when they're right next to each other, or you could have a full moon when they're going to be actually opposite each other and not particularly useful either. I'm not sure how they do it. But when it's too close to the sun, they do it this way. Okay, so those are sort of special features. Now, the other note, let's see, what other notes do I have here? Oh, one of the notes is, okay, just about the accuracy. Generally, there be the same numbers for a given date. If you look at the GHA and declination of the sun, they will agree with each other, but plus or minus 0.1. I notice that in just making this article note, I notice they don't agree exactly. They've every once in a while a 0.1 difference. The overall stated accuracy, and I'm not sure if it's real or not real, but the Air Almanac their just general discussion of accuracy of sites and so forth is a little less accurate, but I think they're sort of folding in the fact that they're anticipating, or these notes were written for air navigators, aviators, and their accuracy of their fixes are going to be a lot worse because they're going so fast and so forth. So that's one difference, but I think the basic accuracy, coming from the same model, same computer program, probably the same. Latitude by Polaris. Now, those who do Nautical Almanac work know that there's three corrections involved in there. There's A0, A1, and A2, and there's standard ways that we do that. A0 is the big correction and so forth. Now, the Air Almanac combines all of those. So I would call that another thing that's a little bit simpler and a little bit nicer. So, and in the end here, we're going to mention that some navigators prefer the Air Almanac. We don't. Okay, so I'll just mention that. Some prefer that, but there's another example that would favor it. The latitude by Polaris corrections are a little bit easier. As far as the star charts that are included, and I don't have examples of those from the Nautical Almanac, but the Nautical Almanac has two standard types of star charts. One one are polar views centered around the North Pole and the South Pole, and another is a strip around the equator in a Mercator projection. Those are not available. Those are not given in the Air Almanac. In the Air Almanac, let's see what happens if I click this. Oh yeah, so you can click that and get this actual map. This is a star map which is well known to celestial navigators, even though they may not know where it comes from. And I can just mention where it comes from is the Air Almanac. And so, but you in this article, you can click that and get that and save it if you want it. So that's a difference there. Sun and moon rising and setting times and procedures are about the same in both books, but they're set up differently. Here is one sort of unique thing, and in a sense, the reason I'm writing this whole article right now is because I want to come back, and I've started it, and I'm going to come back and focus on something that is unique, that is indeed unique to the Air Almanac, and that is the sky diagrams. And these sky diagrams are intended for predicting the best sites to use on a given night. Now, we have multiple ways to do that without the Air Almanac. One is called Pub 249 Volume 1, and that will always tell you very relatively easily the best 3 stars to use under any circumstance, any time or date within the so-called era, within a plus or minus 5-year period of the publication. Volume 1 is published every few years, maybe every 5 years. And good for 8. However, it's only the stars. Volume 1 will tell you the 3 best bodies to take. Presumably they're all stars. But in reality, like you have Venus out there or something, some bright Mars or Venus there, then your best combination is likely going to include Venus, and Pub 249 can't help you with that. Furthermore, you got to have an almanac. Pub 249 doesn't work by itself. You have to have an almanac. Oh, and the other method is you can use a 2102D star finder, which is something we've spent a lot of time on. We have a whole book on that subject. By the way, that book should be linked here. I'll link that when I get done here. That should be linked to our star finder book. And the star finder does include planets. So it does stars and planets, so that's its advantage over the other one. But it still takes some setting up. You have to use a nautical almanac and so forth. These diagrams in the Air Almanac are essentially intended to be used by inspection. No further lookup of anything. You find the time and date, and they're not, and then you go and get your you find the best sites. Now, again, there's a very interesting thing, and I'm going to but it's a little, I have to explain more about how to use these, and I'm going to do that in a separate article. So that's one unique feature of these, of the Air Almanac. And this is a little discussion of that in this short note here, but again, we're going to do it more differently later. So what's the summary here. There's many mariners actually like the Air Almanac. They choose that, small craft mariners. And they also then would use Pub 249, which is popular from sailors, and that is Site Reduction Tables for Air Navigation, and those two work together. We, in our navigation training, although we use 249 to start out the course with, we do, in the long run, prefer the marine publications, Pub 229 for Site Reduction, and on the Nautical Almanac. But the other thing I want to stress, that's the reason that we prefer the Nautical Almanac, is it includes a complete set of site reduction tables. So with the Nautical Almanac, you would have a one-book. The Nautical Almanac is essentially a one-book solution to position finding with the sextant. And that's that one book covers everything you need. Whereas with the Air Almanac, you still have to have a set of site reduction tables. But anyway, those are the differences. Those are highlighting the main differences. You can come to this article here for a little slower, documented presentation of these points, and then with the links. And then shortly, and I'll put a video too if I can, I want to focus in on these sky diagrams to show their unique features. So I'm going to stop there for now on this subject.